So good morning students. So now we are going to discuss about D block elements. See, in your second year, so inorganic chemistry, so that D block elements. Suppose you see in our periodic table, so where is the location of D block elements? So first we have S block elements. Next, so D will be present. Next, so here S block elements are there. Here P block elements are there. Now here D is there. Next, here, so we have F block elements. So now we are going to discuss about D block elements. So what are the properties of D block elements? It is exactly in between the S block and P block. So what are the properties of S block elements? So here we have EP rebel metal. So S block element properties are high electropositivity. Next, Re means reducing nature. Next, basicity. Next, L means loss of electrons. Next, they have metallic character. So in our periodic table, S block element properties are EP rebel metal. Now the P block element, so exactly opposite of the S block elements. So what are that? You can write En, oxy acid non-metal. So simply you can by heart within one line. So the P block element properties are En, oxy acid non-metal. So what are that? Electronegativity is high. Oxidizing nature is also more. Next, acidic nature. So G means gain of electrons. Next, non-metallic character. See, left side is S block, that properties are EP rebel metal. Right side is P block elements, En, oxy acid non-metal. So the middle, so this is D block element. So now we are going to discuss about D. So what are the properties? This properties is exactly middle of this. So here left side S block element property, right side P block element property. In between these two D is there. So these properties also in between the S and P. That. Next, some important points we will see. Before going to D, so you must know all the elements of D block elements. So it is started from which group? It is started from which period? So that is important right now. See, the D block elements are started from fourth period. Fourth period. This is called as 3D series. Fourth period 3D series. What are the elements? So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So that is next fifth period 4D series. So that is yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium. Next, sixth, so you call it the 5D series. That is lanthanum, hafnium, tantalum, wolfram, rhenium, osmium, iridium, platinum, aurum, gold, mercury. So these three groups are the main important these periods. Next, seventh period, so 6D series. So all are radioactive elements, that is started with actinium. See, suppose if you see the atomic numbers, this is 21 to 30. Next, you add 18. So then you are getting 39. You add 18. So you will get 48. Next, again you add 18. So here you are getting 30, 40, 57. So 57 here, lanthanum after. So we have 14 lanthanoids are there. So that's why here 40. So you add 32. So that means here number 72. Next here you add 32. So your number is 80. See here 57 you add 32. So you will get 89. See, after actinium we have actinoids are there. So but all are radioactive elements. So these three periods only we will see. Suppose you write in a modern periodic table, the numbers are started from 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now according to that Mendeleev's, that is Roman letter 3rd B, Roman letter 4th B, 5th B, 6th B, 7th B, next 8th, 9th, 10th, all together we are taken as 8th B. 11th one you take first B, 12th one you take second B. So this is according to Mendeleev. So B indicates what? That is a D and F block elements. Here 11th group. So 11th group are first B. So what are the elements? Copper, silver, gold. Copper, silver, gold. You called as coinage metals. So some special names are there. So try to remember that one. Next 12th group. So 12th group otherwise second B. So what are that? Zinc, cadmium, mercury. So these are called as volatile metals. So means their boiling point and melting points are least. So that's why we call it as volatile metals. Next, mercury. See, all metals are solid in form, but mercury only, so that is a liquid metal. Next, highest melting point, so that is goes to tungsten. So otherwise wolfram. So that. Next, these are called as inner transition elements, and all those things we will discuss one by one. So first of all, the elements are over, the special names. So after that we will discuss one by one. So 8th, 9th, 10th, that three groups are taken as Roman letter 8th B. So that one you must concentrate. So that total 8th B group contains, we have 9 elements. So that is ended with platinum. So that's why you call as platinum elements also. Next. So here some important points. So the properties. The D block element properties in between S and P block. Next, general electronic configuration. So general electronic configuration, that is N-1 D 1 to 10, NS 1 to 2, So already you learned in previous, your first year. So periodic table and its properties. So that will come. Next, general oxidation state. General oxidation state, that is +2 is general, but so many. Detailed we will discuss in the next. Next, these are what? General characters. Next, these are called as transition elements. See, why? What is the meaning of transition? Transition means changing. See, the D block elements we are studied. So D block elements we studied left to right. Left to right in period. So that means what happens if you are moving left to right? So one electrons are increases, electrons are changes. So electrons are changes means what happens? Properties also changes. So that changing word we are called as a transition. So here also our important is except second B, otherwise 12th group. What are that? Zinc, cadmium, mercury. Except these three elements, remaining D block. Remaining D block elements. So except zinc, cadmium, mercury, the remaining D block elements you call as a transition elements. So very important. So in your entrance, if you are going means which of the following is a transition element, which of the following is not a transition element, like that they will ask. Next, suppose we are going left to right, what happens? All properties. So general properties. See, if we are moving left to right in period, so left to right we are moving in the D block. So that's why, so atomic size. So atomic size is what? Decreases. So because of the D block elements we are studied in the form of periods. So period manner. So that means left to right. So in your periodic table and properties in your first year already studied, what happens? Atomic size is decreases. Next, ionization potential. So that is also. So IP values are increases. Next, electronegativity. So that is also left to right. Already we seen we are going towards right side, means P block elements. So that means what? En, oxy-acid, non-metallic characters. So that will be increases. Now, what are the special properties? So the special properties of D block elements. So that is important for us. See, for understanding these special properties, I am providing just one chart. So based on that, you can cover everything. See, suppose if you see this one, so it is looking like in what way? It is a chariot that is moving on the CC road. So that God idol will be there. So upon that umbrella is there. Next, this is pulled by PCM students. So this much you can remember means all our special D block elements will be over. So in what way? See, this chariot is made up of with what? Metal compulsory. So that's why the special property, that is what? Metallic nature. Next. So metal means everyone we are thinking that one positive. So alkali metal. So you call it as +1. Alkaline earth metal. You write +2 only. But these are showing metals but various positive oxidation states. So it has various positive oxidation states. So are present on that. Next. Third. So the wheels are Vp and Mp. So the D block elements boiling point and melting points are very high. So boiling and melting points are very high. Next, they are readily forming complex compounds. So in future, your inorganic chemistry of second year, the complex compounds are coming. So that is the speciality of the D block elements. So CC means you can remember complex compounds. Next, so we are arrange the atoms. So in the middle what happens, some gap is coming. So that gap you called as interstitial voids. So interstitial voids or gaps. So suppose anything is coming and occupying this gap, that we called as interstitial compounds. So the D block elements are readily forming interstitial compounds. Next, suppose anyone is lower state. So lower state we are sending to highest position. So which chemical is doing that one? So that we called as a catalyst. So from lower stage to they are taken into higher position. So means majority of D block elements are acting as a catalytic property. So these are showing catalytic property. Next. So we are written PCM. So PCM students are pulling this chariot. So P means you can think it is a paramagnetic. So these are showing paramagnetic nature. Next, another one is C. C indicates that is a color property. So next M. So that is mixing of metals. So mixing of metals, that is nothing but alloys. So they are readily forming alloys. So mainly these are 9 special properties. General properties compared to other, these are the 9 special. So every property we are explaining here. So our D block element chapter will be completed. So what are that? First one, metallic nature. So metals are showing only one positive oxidation state, but these are showing so many. That is various positive oxidation states. Next, third one, high boiling point and melting point. These are forming a variety type of compounds, that is complex compounds. This is a separate chapter in your coming second year also. Next, interstitial. So that you call as gaps. In the close packing of atoms, some gaps are arises. That gaps are occupied by something. So you call it as interstitial gaps or void. Next. So these are showing special property, that is catalytic properties. Next, paramagnetic. Why these are showing paramagnetic, and we will explain. Next, another property, color property. Next, these are easily mixing with each other. One metal is mixing with other metal, you are called as alloys. So, okay students, previous we discussed the special properties of D block elements are this 9. So one by one we will discuss. So first one, metallic nature. See, first of all, which one you called as a metal? So the substance. So the substance which readily loses electrons. Readily loses electrons. So the substance which is readily loses electrons, that is called as a metal. So that means that D block elements are readily loses. So that's why D block elements readily loses electrons. How much the losing capacity is less than? So if you take metallic nature, so metallic nature, S blocks are more, next D. So in S block also you can take means first A is greater than second A. So that is next only coming to D block elements. So means first group is readily loses their electrons compared to this. See, if these are available in what way? So that is also depending on the metallic nature only. See, these metals, so available in solid state. So except mercury. So readily loses electrons and it is available in the solid form. Why these are existed in solid form? Means suppose you take any metal, suppose iron you take. So what iron is doing? So iron, this iron is loses 2 electrons. So 2 electrons are coming outside. So this is plus 2. Next, this is also plus 2. 2 electrons are coming outside. Next, iron is plus 2. 2 electrons are coming outside. Next, you take another iron. It is also plus 2. 2 electrons. So another iron plus 2. 2 electrons are coming outside. So here, so electrons, outcoming electrons not only attract their original iron, the beside iron also it is attracted. So the beside iron also it is attracted. So that means outcoming electrons you called as a free electrons. So free electrons are attracted not only one ion, so many beside ions also, because of this electrostatic attractions, plus and minus. So that is electrostatic attractions. So their close arrangement is observed. Close arrangement. So close arrangement is observed means that only you call as solid. See, the attraction between metal ion and free electrons is called as metallic bond. So here the important one is metallic bond. So what is the meaning is the strong electrostatic attraction between metal cation and free electrons, so is called as a metallic bond. So strong metallic bonds are there, so then close packing is more. So that means what happens? Solidifying nature is coming. So metallic bond nature is increases. So attractions increases. So attractions are increases means solid nature is coming. So because of this free electrons only, so you are getting metal gets what? Shining nature. So another important point here, due to free electrons, metal is shiny. So whatever we are going to discuss, every concept is linked up with this free electrons only, majority. So everything we will discuss. So this is about the metallic nature. Next, here in this, everyone is solid, but mercury is liquid form. So that also you can write it. So mercury is in liquid state. So the mercury is in liquid state. Why means liquid means what? The metal and metal is far away. So attractions are low. Why it is showing means attractions between metal cation and free electrons is low. So that's why they are far away to each other. So far away to each other means what happens? This is only not solid form. So that means it is available in liquid form. So why these attractions are very low? So that also important due to lanthanoid contraction. So this word you can heard in your atomic structure and so periodic table and its properties in your first year. Because of lanthanoid contraction, the free electrons are very coming out is less. So that means attractions are low. Attractions are low means metal cations are far away. Far away means they are available in liquid form. This is. Next, second one, various positive oxidation states. Second one, various positive oxidation states. See, the metal means, so metal is losing electrons. So losing electrons means it becomes as positive. So upon the metal surface you are getting positive charge. See, metals are showing only one positive oxidation state, but D block elements' special character is what? Various positive oxidation states. So many it is coming. Suppose you take a 3D series. So 3D series elements, if you take means scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. See here. Everyone is showing +2 oxidation state. So zinc. So everyone is showing +2 oxidation state is a general oxidation state. Next here, while writing the chromium 24, so this one you can write 3D5O4S1 electronic configuration. So copper 29, so that you can write 3D10O4S1. So oxidation state here 4s1 single electron is available. So half filled electronic configuration after one single electron. So that's why these are showing +1 and +1. So chromium and copper both have capacity to show +1, but copper +1 is more and more it is available compared to this. Next, in the total, this series, if you see, manganese is showing the highest oxidation states, +4, +5, +6, +7. So maximum manganese is showing a +7 oxidation state. Next, continuously decreases. So 3, 4, 5, 6. So 3, 4, 5. Here 3, 4. Here plus 3. Next, if you take this side also, so it is also continuously you decrease. So here, so you take manganese is showing a major plus 7, remaining continuously you decrease left and right side. Suppose if you take iron, so iron is showing so many oxidation state, in that plus 2 plus 3 is famous. So remaining they will come and go. So that is, suppose you take manganese, plus 2 famous, plus 4 is famous, plus 6 and plus 7 is famous. But plus 3 and plus 5, they will come and go in the middle of the reactions. So in all the oxidation states, some are stable, some are unstable. So anyhow, everyone is showing a different oxidation states. So in that, some important we will see. Next, if you see the detailed properties means, see, so one important point, already we discussed S block elements, you take P block elements. So which size is more? So S block size is more. So P block size is small. So what are the properties are here? EP, rebel, metal. What are the P block element properties? En, oxy, acid, non-metal. So always you remember, S block large size has EP rebel metal, small size has En oxy acid non-metal. See, suppose if you take manganese, manganese is showing plus 2 is there, plus 4 is there, manganese plus 7 also there. See, positive charges increases. What happens to the size? So that is, in your basic only, positive charge. So positive charge increases, size is decreases. So this is also you must learn in your first year, periodic table and its properties. Negative charge increases. So that size, atomic size or ionic size is gradually increases. So positive charges increases. What happens to the size? It is decreases. So it has what? Large size. The size is decreases. So large size is there. What will be the property? So that is what? EP rebel metal. Small size is there. What is the property? So this is EP rebel metal. So Mn plus 2 has high electropositivity, reducing nature, highly basic nature, highly loss of electrons, and it is showing metallic nature. So here you are coming to Mn plus 7. So what is the property? En oxy acid non-metal. So in what way your examination, suppose they will ask MnO, MnO2, KMnO4. In these three, which is acid, which is base, they will ask question. So then how you can tell? So you can take the oxidation states. So it is what? Plus 2. Oxygen is minus 2. Here oxygen is minus 2. 2 oxygens are there. So manganese is plus 4. Next, KMnO4. 4 2s are 8. Minus 8 plus 1. Here plus 7. So manganese here plus 2, here plus 4, here plus 7. So plus 7 has what? En oxy acid non-metal. So which one is acidic nature? So that's why you can tell this is acidic. So this is Mn plus 2. You can tell as basic. Next, suppose they will ask which is oxidizing agent, which is reducing agent. So you come and see plus 7 is oxidizing. So plus 2 is what? Reducing. So that's why it is acting as a reducing agent. It is acting as oxidizing agent. So like that. What about this one? So it is the exact middle of these two. So that's why it is doing reduction also, oxidation also. So this is exactly middle of these two properties. So like that you can analyze. Next, some other oxidation states we will see. See, that is the first B group. First B, otherwise 11th group. So what are that? Copper is there, silver is there, gold is there. So the copper is showing Cu plus 1 also, Cu plus 2 also. Silver is showing Ag plus 1. Gold is showing Au plus 3. See. So lowest oxidation state you called as As. Highest oxidation state you called as Ik. So Cu plus 1 you called as cuprous. Cu plus 2 you called as cupric. That. So silver is showing plus 1. See, these three groups, elements are showing what? Three different oxidation state. So you must concentrate gold. Gold oxidation state is plus 3, not plus 1 and plus 2. That. Next, second B. Second B, otherwise 12th group. So what are the elements? So zinc, cadmium, mercury. So zinc is showing plus 2 oxidation state. Cadmium is also showing plus 2. Next, mercury is showing plus 1. So this is also you can show in some books. Hg2 plus 2. So Hg2 plus 2 similar to Hg plus 1. Next, Hg plus 2. So here also same thing. So lowest oxidation state you called as As. So highest oxidation state you called as Ik. So mercurous, mercuric you can call. So that entire formation of compounds is depending on oxidation states only. So that's why oxidation states are very, very important. Suppose you are taken iron. So iron is famous with 2. So what are that? Fe plus 2. Next, Fe plus 3. So Fe plus 2 you called as a ferrous. Fe plus 3 you called as ferric. So that. Next, in total periodic table. So in total periodic table. So osmium is showing highest oxidation state, that is plus 8. So in osmium tetroxide, OSO4. So this is also important. In total periodic table, highest oxidation state, that is a plus 8, shown by osmium in OSO4, osmium tetroxide. Next. So third one. So boiling and melting points. So third concept, high boiling point. High boiling point and high melting point. See, what is the meaning of that melting point and boiling point? See, if metal you take, metal is in the form of a solid. So solid we are heated. We are given temperature, it becomes as a liquid. Next, again we are heated. So it becomes as a gas. See, So this temperature you called as melting point. The temperature at which solid become as liquid you called as melting point. The temperature at which the liquid become as a gas, so that is called as a boiling point. Say how much temperature you are going to give, that is depending on the attractions. So attractions. So which type of attractions are there here? So already we seen metal is there. So metal is loses electron. So that is coming outside. So that coming outside electron not only contacted with, see this is not only contacted with this metal and other metal also. So that's why what happens here, strong attractive forces are there. So that's why this is only metallic bond. Strong attractions between metal ion and free electrons. So this is only you called as a metallic bond. So attractions are increases, metallic bonds are increases, that means automatically you break this metallic bond, you must supply more amount of heat. So that's why your boiling point, melting points also increases. Next, this boiling point and melting points are irregular. See, melting points are irregular due to, see, this crystalline structure. Suppose you are going left to right, either increasing or decreasing, so that is depending on the, not only this attraction forces, that is depending on crystalline structure also. So that's why melting and boiling point both are irregular manner. So that means sometimes it is increases, next decreases, next increases, next it is continuous. Suppose scandium, titanium, vanadium, next chromium up to manganese, so cobalt, so that is increases, next up to zinc, so suddenly decreases. So sometimes it is increases, decreases, increases and decreases. Why it is happening means it is depending on the crystalline structure as well as attraction forces. So this is. Next. Fourth one. So formation of complex compounds. So fourth one, formation of complex compounds. See, these complex compounds also similar to our ionic compounds. See, suppose you take NaCl. So NaCl is an ionic compound. So you take into the water. So then what happens? Na plus Cl minus. It becomes in the form of solution. So in water, Na plus Cl minus is dissolved. Suppose if you see here, so you are getting Na property. So sodium property you can identify, Cl property also you can identify. Next you come to into the solution. Here also sodium properties, so that means ion property, Cl minus. So the properties you can identify in the solid state. In the solid state also you can identify sodium and chloride. In solution state also you can identify sodium ion and chloride ions. So this is called as a normal salt. But some compounds, so that is made up of with salt made with D block. Suppose one you take K4, FeCN taken 6. See, this is the D block element solid. So iron is there. Iron is there means a D black element. You take into the water. If you take into the water, what happens? 4 potassium ions are coming outside. Next, you are getting FeCN taken 6 minus 4. So single iron is not coming outside. The 6 cyanide ions are not coming outside. Suppose in the solid state you see, this is dissolved state. So means a solution state. In the solid state, which properties you can identify means potassium property you can identify. So iron property you can identify. So cyanide property you can identify in the solid state. If you take into the water, what happens? So here. So potassium properties we can identify, but what happens? Iron property you can't identify. Cyanide property you can't identify. But what happens? FeCN taken 6 minus 4. This new property. So new property you can identify. So that means the chemical substance which is loses their original properties in the solution state, that you called as a complex compound. So the D block elements also forming some ionic salts, but they are dissolved in water, but they loses their own properties. So that's why they called as a complex. Complex is nothing but not identified easily, your English word. So we called as a complex compounds. So in your second year, this is complete separate chapter only. So detailedly you can discuss in the complex compound chapter. Next, 5th, interstitial compounds. So 5th one. So interstitial compounds. See, already discussed. In D block elements, what happens? They are showing metallic nature. So because of metallic nature, what happens? So strong metallic bonds are there. It contains strong metallic bonds. What strong metallic bonds? The attraction force between metal cation and free electron. So metal cation and free electron attraction force is called as strong metallic bond. This strength is more. Then what happens? Metallic nature is increases. So then what happens here? Close attractions, close packing is observed between ions. So the close packing is observed between the ions means, so what happens? They are come close to each other. So they can arrange. So in different manner. So in your second year, solid state chapter is there. So in that solid state chapter also you can identify different manner. So it is here what? Diamond shape. So gap is coming. So here just you take a V shape. So this is one type of arrangement, close packing. This is another type of close packing. So here, so you are getting what? Void. So otherwise gap. So otherwise you also called as interstitial space. So these are. So in the close packing, why close packing is happening means because of this metallic bond. So strong metallic bond, they are come close. In the close means what happens? Some gaps are arises. So that gaps you called as voids, otherwise interstitial space. In the D block elements, what happens? In that gap, So they are occupied with some small elements. So which one you call as interstitial compounds means that voids or gaps occupied with small atoms. So small atoms like hydrogen, carbon, oxygen, nitrogen and so many. So small atoms are there coming and packing inside the gap. So that you called as interstitial compounds. So that example if you see means see platinum, nickel, palladium, rhodium. So these are covered with hydrogen. So the gaps of platinum, nickel, palladium, the hydrogen is fixed. So that is an interstitial compound. See next tungsten. So tungsten also, tungsten gaps are occupied with carbon powder. Next iron. Iron gaps are occupied with carbon powder. Then this is only you called as a steel. So what happens if carbon is connected, strength is increases. So interstitial gaps. So happened occupied with some other atoms means the strength will be increases. So that physical strength. So chemical properties are same. So chemical properties are not changing. So only physical properties only changes. So the same. That element is not loses their own characters, but physical properties only changes. So this is important. So compared to tungsten, tungsten carbide is more strength. Compared to iron, iron with carbon, so that only you call as steel. So that is a more strength. So that is about interstitial. So in entrance point of view, what will be the important means chemical properties, physical properties. So chemical properties are not going to change, only physical properties, you remember. Next, fifth property over. Now catalytic property. See, catalytic property, what is the meaning of a catalyst? So which one you called as a catalyst means the chemical substance. The chemical substance not directly participated in the reaction, but increases the speed, of reaction. So that you called as a catalyst. So how these are going to do this one? So that means so these are acting as a middle. So what the chemicals are doing? Suppose if you take D black element. So D black element contains what? So many positive oxidation states are there. So much of positive oxidation states are there. Empty orbitals are there. So positive oxidation states. So positive oxidation states are increases. So that means what? Positive charge is increases. Positive charge increases means the attraction is increases. So the attraction only you called as electronegativity. So electronegativity increases. Next, it contains so many empty orbitals are there. So then what happens? Suppose you take a reaction. So hydrogen react with oxygen, just you are heating highest temperature. So then what happens? Hydrogen is bombarded with oxygen. So then only they are going to become as a water vapor. So this is a general reaction. Suppose here you are using more and more temperature. So highest pressure is required. So because of in one container we are taken, hydrogen is one side, oxygen is one side, the bombardment is very less. Suppose you introduce our D block element inside, so then what happens? See, hydrogen is far away, oxygen is far away. First of all, these D block elements, oxidation states are more, so that means electronegativity is high. So it is attracted by hydrogen and it is given shelter to the empty orbital. So oxygen also attracted by on the surface of D block element because of highest electronegativity. So now hydrogen and oxygen, they are come close to each other because of D block. So then what happens? They are getting bombardment with each other. So that's why it is easily become as water and it is ejected from the surface. So this is you called as catalyst. See what happens? This is not participated in the reaction. So it is attracting that one. So hydrogen and oxygen, their personal energy is decreases. So now they are bombarded. So fruitful collisions are happened between hydrogen and oxygen. They are easily become as water and it is ejected. So what are the conditions for D block elements are showing catalyst means? One is positive, highest positive oxidation states. So then electronegativity is increases. It attracts every molecules on its surface. So second point is empty d orbital. Suppose it is attracted molecules, where they can stay? So they can stay in the empty orbitals. So the two possibilities of these two, this is acting as a catalyst. So